Hi there. Welcome to Bioaccumulation, Actions and Effects, which is brought to you by Loveland Open Lands and Trails, a division of Loveland Parks and Recreation. What is Loveland Open Lands and Trails? Well, the Open Lands and Trails program has preserved over 5,000 acres of open space in and around Loveland. As part of our mission, we offer field trips to our sites, public programs, you should come to one this summer or fall, and monthly opportunities for you to learn more about our natural areas. The following lesson is designed to support a field trip and a program hosted at Veenstein Smith Mountain Park. This lesson ties in with the Life Zones lesson and the Closing the Loop lesson. You may stop this lesson at any time for questions or discussions in the classroom or to complete a task suggested within the lesson. Bioaccumulation is often mentioned when talking about chemicals. One example that you may have heard about are PCBs. Others might include DDT, or heavy metals like lead, mercury, and selenium. DDT is a famous example because it was used in the 1960s and resulting in thinning eggshells of many birds. When a parent sat on the nest, the eggs were crushed. We revisit the selenium example later, but do you notice this horse has no tail, no mane? Bioaccumulation, what is it? A definition of bioaccumulation. It is the accumulation over time of a substance and especially a contaminant, such as pesticide or heavy metals, in a living organism. Bioaccumulation is a process of accumulation of chemicals in an organism that takes place if the rate of intake exceeds the rate of excretion. Chemicals are introduced to the organism through exposure to the abiotic environment or as dietary intake. Exposure equals car exhaust. Dietary intake, like the cow eating grass in a pasture. Our next slide contains the vocabulary for this exercise. You may want to get a piece of paper. Abiotic, non-living parts of the environment. Dietary intake, what is eaten. Excretion, pee and poop primarily, but also sweat. When used according to the directions, many chemicals can be beneficial and do good things for us. It is contaminants that are the cause for concern. When these chemicals get to places they should not be, they have effects beyond their purpose. And how many people do you know that read all of the directions or dispose of leftovers properly? Pesticides are chemicals used to get rid of pests such as insects, small mammals, fish. Herbicides are chemicals used for getting rid of weeds and things like crabgrass. Heavy metals are chemical elements with a high atomic weight and a density at least 5 times that of water. They are known for their harmful effects. These include lead, mercury, selenium, cadmium, and arsenic. A chemical is any substance that is a defined composition. In other words, a chemical is always made up of the same stuff. Some chemicals occur in nature, such as water. Other chemicals are synthesized in labs. As long as the components are always the same, many things are considered chemicals. Bioaccumulation begins where all food chains begin, with plants. So why are plants so important? Plants provide shelter, they provide food, they provide oxygen, and they provide water. Plants provide water, for example, for javelinas, wild pigs of the desert. They get water from prickly pear cactus. Hummingbirds get enough water from the nectar they sip. Several insects and small mammals can get their water from moist plants. And what would happen to animals if there were no plants? animals would die without plant life. All life would die without plants to turn solar energy into chemical or food energy. Plants are the origin for every food chain on the planet. A food chain is a diagram of the energy flow through living organisms and feeding relationships between animals. Plants are the only things that can photosynthesize. All of our energy comes from the sun. This energy can only be converted by plants into various forms that we use for food, clothing, shelter, fuel, etc. No plants, we all die. Only the abiotic environment will remain. Pretty hard environment to live in, right? Think about where plants grow or how they are grown. We have acres and acres of farmland that is some of the most productive in the world, in many cases due to the chemicals that control things that compete with crop production, such as insects, fungus, and other plants, like weeds. This video clip shows one way pesticides, herbicides, and even fertilizer can be applied. Can you see that many plants will carry with them, on their surface or within their cells, chemicals which will be carried into the bodies of animals that eat the plants? Many of you are familiar with the basic food chains, the who eats who chain of critters. Have you always remembered to have plants at the beginning of your food chain? Have you always had decomposers at the end, helping to return the energy and nutrients back into forms plants can use? In order to really talk about bioaccumulation and the potential damage it can have on living organisms, you must have a food chain that begins with plants and the water, air, and soil that they use. Solar energy is taken in by plants and through photosynthesis converted into chemical energy. The plants convert water and carbon dioxide to glucose and other carbohydrates used for growth, maintenance, and reproduction. Plants are the producers of all our chemical energy. Wouldn't it be great if we could stand in the sun and get the energy we need? Instead, we are one of the consumers. Primary consumers are eating the plants. Secondary and later consumers are eating other consumers. Tertiary means third order. Final consumers are whoever is last in the chain before dying and having their energy returned to the system by decomposers, like invertebrates, fungi, and bacteria. In any food chain, all links are dependent on each other. If one link is broken or affected in some way, all other links will be affected. A food or energy pyramid illustrates how one apex predator requires more than one smaller animal to satisfy its energy needs. A barn owl catches and consumes several mice and voles. A red-tailed hawk will catch and consume snakes and small animals of all kinds. It takes a lot of producers or plants to feed the many mice. And what if there's something on that grass? A pesticide or herbicide to kill bugs or weeds. We represented a chemical on the grass by the small dots. And many mice or other small mammals are needed to support a snake. Each of those mice ate the plants. Some of them had chemicals. So now if each mouse ate 3 dots worth of contamination, how many dots or how much chemical would be in the snake that ate 3 mice? 9 times the amount originally on the contaminated piece of grass. And more than one snake or a few small mammals are needed to support a red-tailed hawk. If the snake eats 3 mice and the hawk catches that snake and eats 2 more mice, how many dots? How much of the chemical is now in the hawk's system? Some energy at each level is used or lost before it goes into the next level. The energy is used for growth, reproduction, gathering food, staying warm, hunting, etc. Nutrients and energy for living are passed from level to level, and contaminants can also be passed up the chain. So how much of the chemicals now in the hawk system? 9 plus 6 equals 15. 15 times the amount originally on the plants. This is an example of bioaccumulation. A toxin such as DDT used to kill insects can accumulate in the last predator's system, in this case the red-tailed hawk. It may not kill them outright, but in case of DDT, it made the eggshells thin. Too thin to protect the embryo or the chick growing inside of the egg. What if it happens year after year with no chicks being hatched? Have you ever decided to go fishing somewhere and found a sign like this? Actions such as dumping waste and chemicals into a river or letting it flow through storm drains can have the effect of bioaccumulation of heavy metals and other contaminants in aquatic life. Try this one. The duck consumes chemicals taken up by the plants or other feeders, fish, etc., in the pond. Some is transferred to the tissue in the eggs. If the snake eats all 5 eggs, how many bits of chemical will be in his system? 10 times the original amount. The hawk has fed on 4 mice from our energy pyramid and now has caught this snake. So how many bits of chemicals have accumulated in the hawk? The mice had 3 bits each. So 4 times 3 equals 12, plus 10 equals 22 times the original amount. This could be a problem. Maybe not right away, but we have lost hawks and other birds of prey in the winter time because of their having to burn fat to stay warm when prey is scarce. The chemicals stored in their fat, not doing much harm, are now released into their bodies too fast, harming their brains and nervous system, causing death in some and handicapping others. The following slide shows things you can do to become more aware of bioaccumulation and ideas of how you can help prevent more chemicals from ending up in the wrong places. Good actions can have good effects. Watch this 5-minute video about selenium. We are here with local horse owner who has some information to share with us relating to our topic on bioaccumulation. Please tell me your name and what substance you're here to talk about.
My name is Michelle, and I am here to talk to you about a substance that can be found in the soil, and it is selenium.
Correct me if I'm wrong, but selenium is a needed nutrient, a required element, isn't it?
Yes, it is, actually. Both humans and animals need selenium, but we need it in very small amounts.
That's why selenium is often referred to as a trace element, right?
Exactly. We only need a little bit, but it's very important. We need it for reproductive health. We need it to fight infections. We even need it to help control some of our hormones.
But too much is bad, and what can too much selenium do to a horse?
Well, too much selenium can cause a lot of problems. In fact, the hair starts falling out of their tails, their mane starts to fall off, if it's really bad, their hooves slough off, they basically go bald.
Oh, now is this something specifically we need to worry about in this area? Have there been any cases here?
It's not too common, it really isn't. But I did check in with our horse vet to see how many cases he might have seen. And I was curious because people are warning us off buying hay from fields that are near and down below by the Big Thompson River. And he said he had a lot of cases in 2013. And it was because after the flood, when the water just spread out and brought down all kinds of silt and rock, the soils had a much higher selenium content, and so the grass and hay had a much higher selenium content.
Wow, with all the destruction that brought and that, I wouldn't even think of that as an afterpiece. Now, I did some research, and I want to verify it with you. It says seleniferous soils, and I'll get that word one of these times, are often characterized by alkaline soils.
And we have alkaline soils.
Okay, and that's developed from shales.
Which we've got.
Yep, and are located in arid or semi-arid climates.
Which is definitely Colorado.
Okay, I thought so. Thank you for that. So is the selenium in the soil taken up by the plants?
It is. It's taken up by the plants as they grow. And when it's grazed, green, the plants have a higher water content, they're a little bit bulkier, and it passes through the horse pretty quickly. So it's less likely to be a problem. But when you have dry forage, when you dry the grass and you pack it into a flake of hay and you throw that flake of hay to the horse, they're getting a more concentrated feed.
Okay.
And a lot of times they don't drink as much water in the wintertime because it's cold. And so that selenium is staying in their system longer. They're absorbing more of it. If you feed a nutritional supplement that's got supplemental selenium, because it is a required element, they could be getting a double dose.
Oh, okay. That makes a lot of sense. So would it be a good idea to get your hay analyzed for nutritional content?
Yeah, it's always a good idea, especially if you don't know where your hay is coming from. A lot of times when hay is in short supply, the bottomlands will start getting harvested. And if you don't know that's where your hay is coming from, you might be getting a high selenium content.
So where can someone get their hay analyzed at?
You can take it to CSU Extension.
Okay.
There's a lab in Greeley, and some companies like Nutrina will let you put samples in an envelope and mail it off to them, and they'll send you an analysis back.
Oh, that's great to know. So what does checking and analyzing your hay cost?
The cost varies. It depends on who you send it to and how many things you're checking for. And if cost is a problem, there's some things you can do. Get together with the neighbors, put some samples in from all the fields that are in like the same area. You can also look for plants that take up a lot of selenium. And one of the ones that's an indicator plant is milk vetch or princess plume. Both of them are varieties of astragalus.
Aha, okay.
Yeah, so if you've got this flower, you probably have a lot of selenium in your soil.
Okay, and have you had that here?
I've had some growing in my front yard.
Oh boy.
And we're several feet above the Big Thompson River.
Okay.
And as you go down closer to the river, the first pastures we visited where I got this information, there's a lot growing.
Oh, so it's a current problem and it's regular. So, Michelle, thank you. This is really good information to know, especially for anyone that buys hay. So remember, you can return to the beginning of this lesson to see a balding horse on the first slide of the lesson. On this slide, there are 2 links for some interesting videos. One shows how people tried to convince the public that DDT, an insecticide, was safe. Imagine getting fumigated while eating lunch. The second shows a modern video clip of a farmer who has used Roundup. After watching the videos, check out the discussion questions and maybe watch the other short videos about DDT. This chemical is the one that caused eggshell thinning and the drop in bird populations, leading to the book titled Silent Spring. Thank you for watching. We hope you get a chance to visit your Loveland open lands and trails.